Okay, so here's the new example this year, right? It says, let's explore some limits that we must carefully heed the warning above note. So again, one-sided limits can change to two, two-sided limits can become one. This is from the 2016 exam. It says to evaluate the limit as x goes to 0 of f of 1 minus x squared. Okay, so much like the warm-up, this is composition. It's not f times, it's f of, and it's more than x. So if you're going to rewrite it, you can. This is f of the limit as x goes to 0 of the function 1 minus x squared. Now, if this were the only question we had, you can use direct substitution and get 1 and be done with it, right? It is approaching 1, indubitably, without a doubt, okay? So 1 will be our new value that we're approaching. The output of 1 becomes the input. And as I mentioned yesterday, you have to be careful. You can't just replace that with 1 because now you're talking about a function value and we need to keep it in the limit value. So it's not equal to f of 1. But 1, which remember was the output, this is now your new x value, but it becomes the value of x that we're approaching on the next layer, which is f of x. The problem is we can't always just assume that it's going to be from the same direction. If it starts as a general, it doesn't necessarily stay a general. It can switch to anything, and it depends exclusively on the nature of the function. So we need to know what the graph of 1 minus x squared looks like. So quickly off to the side, your parent function is x squared. It's shifted up 1 unit. The vertex is still on the y-axis. It looks like that. Now look at this. This is going to be a little bit easier for y'all to understand, hopefully. And I'll take full credit for not doing it clearly enough. Yes, as I approach 0, the general limit, it's approaching 1, without a doubt. We know that. But notice it's approaching 1 on both sides from below 1. Below 1, okay? Think of the y value that it's approaching, again, as a horizontal line that divides the plane into 2 regions. The positive region, okay? This is going to be above. Just a second, Ethan. And then the negative region, sorry, I'll use gray instead of blackout, right? We still got to talk about that. This would be the negative region, which is below. It's kind of like in Algebra 2 when you shaded inequalities, right? Okay, so because outputs become inputs, the y value of 1 that we're indubitably approaching has to now be approached from a particular direction. And on this graph, from both sides, we're approaching 1 from the negative direction, okay? So, as Mason said, when we approach 1, we now have to approach from the negative side. Okay? Yes, now question.
If you have like both directions, does that mean the general?
Yeah, very good. So I was going to address the other cases, right? If this graph, if it's a general limit, which means we consider both sides, and it's crossing from high to low at that y value or low to high, doesn't matter how it crosses. If it's a general limit, it stays a general limit because it's doing both sides. If it bounced and turned up, now we're approaching the positive from both sides. It would have to be from the right-hand side. What we did in the warm-up is it started as a one-sided limit. So if it starts as a one-sided limit, you have to keep it a one-sided limit, but now you have to look at just what side it's approaching. So if it was a limit from the left, it would be from below. If it was a lit from the right, it would be from below. That makes more sense. Well, yeah, if it starts as a general, then you consider both. And then if that graph crosses, it would be still a general limit. Yeah. Okay. All right. So yes, now that we have from the left, we had a two-sided limit turned into a one-sided limit. Now I can come over here to this graph and look at the limit from the left of 1. What's the limit from the left only? 3. Good, good. 3, and the answer is 3. Okay. See, what most people were doing before this was emphasized is it was like, well, if it's just started as a general limit, it stays a general limit, and there's a jump there from both sides. It's two, so it's D and E. And guess what answer choice E or D always was? Non-existent, right? So this is one of the things we're trying to come back and not just teach it in a better way, but teach it correctly, really. There's little bitty things like this that come out every once in a while. All right, so hopefully that makes more sense. And notice if you just called it F of 1, like I said, don't do it, that would be, 2, and that's an answer choice as well. Okay, so having said that, go ahead and do this one on your own. It says you try this part C, but y'all are ready to try part B. Dang, I need to borrow a mousetrap. No, I lost my mouse from my computer. The one's in the ceiling. Oh, there it is. Sorry. Okay, so we have now f of x. So in this case, instead of being given a function like 1 minus x squared that you're expected to know the graph of, it's just a double composition of the same function here. So step 1 is to bring it inside. That's what I would recommend. So f of the limit as x goes to 6 of f of x. Okay. Now this is a general limit on the inside, so we treat that first. We have to look from both sides, just like always. So we come down here and we look at 6, and it's continuous at 6. So for sure the limit's going to exist, and it's obviously 2. Now again, just a warning, don't do a direct substitution, right? Hopefully no one's doing that, because we have to keep it in the context of a limit. So let me just state it again this way. It might help you with the transition. 2 is still going to be our new input. Still. It's still going to be our x value, but it's not the x value we're going to go stand at and say, what is f of 2? It's going to be the x value that we approach. We are now going to be approaching 2 on the next layer, which happens to be f of x again. But we do need to figure out, is it still a general limit, or did it change to a one-sided limit? Well, that depends on how we were approaching 2. So again, 2 in this case is a y value. Think of it as a horizontal line that divides the Cartesian plane into 2 planes, right? You have positive up above, and then you have negative down below. As we approach 6, we are approaching 6 from above 6. As we approach 2, sorry. As x approaches 6, we're approaching the y value of 2 on both sides from above. This graph stays entirely, if you will, on the positive side of 2. 2 itself is a positive number. We're not thinking about it in that terms. We're thinking about it from above 2, which is the positive side of 2, on both sides. So this changes to a one-directional limit, exclusively from the right-hand side, okay? And now when we approach 2 on the same graph, from the right-hand side only, we're approaching what? 5. If you understand that, we're kind of clearing the fog. Yeah, okay. No, question. Here, we go in this. Okay. I high-fived her to just try. Okay.
Well, I get it, but
yeah, good.
when do you do like this? Whenever you have like the since this doesn't equal this.
Right.
Like when would you do that? Oh wait,
that's when it's a single limit.
Okay,
The reason that we're doing this twice every problem is because it's composition. That's the only reason.
right.
It's something inside of something else. It's not something added to something else. Okay.
So since I need to ask, you get your second input, you never want to do a general limit of that because it's obviously
correct.
RBT.
Well, it could still be a general limit. When would my second iteration on the composition be a general limit? If I had crossed this horizontal line, if it would have been positive on one side and below on the other, in either direction, like this or like this. You can't see it on the video. then it would still be a general limit. Yes, question behind you.
I think that's so. If it was coming from both directions,
Yeah.
then when you did the second limit, you would have to go like opposite directions first to get both sides.
No, you would just keep it a general limit. You would still look at both sides. If this graph were not a parabola here, if it just shot straight across the line y equals 2, from low to high, why would you? Because you're looking at both sides to begin with, right? It's approaching from the negative side on one and the positive side on the other. And it doesn't matter the order. If it's still approaching from above and below on either side, you have to look at from the left and right, which is still the general limit. Okay, we'll go back and do it. Yeah, question.
So like, say you're approaching 2.
Mm-hmm.
You come from below, but there's like the whole other graph right there. Would it still be?
It's too far away from.
No, so it
You just look really in the immediate vicinity.
So it would still, it would change. So say there was another f of x, it would be limit of f of x as x approaches 5 from.
5.
No, this is a theory. This
Oh.
isn't part of it, but I'm asking just like in case this happens in the future. Say there was another. Right.
Oh, another one. Right. Yeah. Oh, yeah. Then it would. Yeah. Okay. Let me address that. Mason had. I understand what he's asking now. What if instead of f of x, this were f of x? Okay. So 5 is now our output. It's our final answer because we're done. Let's look to see how we were approaching 5. I was approaching 5. Where was right here? I circled it. It's the open circle, right? As I approached 2, I was approaching 5. Done. But now if I have to let 5 be my new input, from where am I approaching 5? Exclusively from the negative side. So that would turn to a left-sided limit. Yeah. Correct.
Okay, I get it.
Yeah. Now, let me, oh gosh, those 14s get in the way. What if I was approaching, does this cross at another nice, yeah, what if this was approaching, let's say that this point is the 0.43, okay? Let's do this. Let's say that's the 0.43. Let me write another question here. What if this is, the limit as x goes to 4 of f of x? Okay. Well, you would take it to the inside, f of the limit as x goes to 4 of f of x. And we evaluate this first. Well, it's a general limit at 4, isn't it? So we approach 4, and as we approach 4, it looks like the y value is approaching what? 3. So we know the next input is going to be 3 on the next iteration. But the question is it one-sided or two-sided? Well, draw that horizontal line now at 3. And notice that everything above is still positive and everything below is still negative. Okay, so here's the negative side of 3, and then here's the positive side of 3. Notice that as I approach 3 from the left side of 4, I'm approaching from the positive side. And as I approach 3 from the right side of 4, I'm approaching from the negative side. So I'm approaching from both the positive and the negative sides of that y value. Therefore, when 3, the y value, becomes my new input, I have to approach it from both the positive and negative side horizontally, which means it's now a general limit. Okay, boom. No.
The question I was asking.
And now, as I approach 3 from both sides, it looks like I'm approaching 4. It just kind of turned out that way, okay? Yeah. All right, let's do another one. Yeah, let's do another one. Again, you try, part C. You try, and look, I spiced this one up kind of a bit. Try all 4 of these on your own. And I'm going to pause the recording. All right, we're recording. So, again, I'll go through these. Now that you know how to do them, as I go through them, you should be like, yes, yes, and more yes, right? And if you have a question, just ask. It's k of x. That's composition. That is sequence, right? So first step is to bring this inside. And again, if you're working straight down, your notation has to be spot on. The first one should be easy, okay? The general limit at 3. So if you look, here is 3. As I approach 3 from the left, I'm approaching 1. As I approach 3 from the right, I'm approaching 1. So 1, which is my output, will become my new input. I'm not even going to write does not equal k of 1. I don't think I need to do that anymore. So what is it going to be? I am going to be approaching 1. I'm going to put a little sign, highlighter there, because I'm going to come back on the next layer, which is k of x. That goes right there. But I need to decide, because it's composition, how I'm approaching 1. So if you look over here, as I approached 3 from the left, I was approaching 1 from above, which is the positive side of 1. And as I approached 3 from the right, I was approaching 1 from the negative side of 1. Again, think of this as divided on above and below. This is both sides of 1. This is both the positive and the negative side of 1. So as I approach 1, I need to approach horizontally now from both the positive and negative side, which means it needs to be a general limit once again. Boom. That's important, right? Everyone okay with that? Good. All right. So now I'm going to go over to 1, and I'm going to look at the general limit. From the left, it's 1, and from the right, it's 2. Does 1 equal 2? No. So now, because it's the end, I can say DNE. And if it asks you to justify, it would be because you would write it out. The limit from the left of 1 is 1. The limit from the right of 1 is 3, and they don't equal each other. Okay? But if it doesn't ask you to justify, you can just put the answer. All right, everyone good with DNE? Good. Y'all did a good job of kind of hashing it out amongst yourselves as well.
Since I like working inside out, do I have to write like the limit inside of the parentheses, or can I just like do it?
If you do this off to the side, yeah. Because you're not actually putting the k of x out there.
Yeah.
Yeah. That's fine. That's fine. She's asking, do I have to put the k on the outside on that first iteration? Will I lose points? Well, that means she's doing it like this. And then are you putting equals 1 here?
No, I was just doing like.
You're just writing it? Okay. Okay. Here's the thing. In general, if you work vertically, you're kind of saying that they're equal to each other. So if you're just going to write that to help yourself, maybe do it like that, and then maybe do this over here like that. Because now you're not lying. Now you're not saying that one of them equals the other. Because they really only equal each other if you keep the k of x in front of the first limit. Yeah. Oh, actually, no, get rid of this limit. Because we're just taking, we're not reproducing it because it's really not in 2 places yet. It's just going inside. Because composition is different than multiplication. With multiplication, you can reproduce it and put it in front of each factor, which is already there. Think of composition as like a time release vault. You have to do the inside first. The outside's not even there. And now you do the inside, and now open sesame. Now the outside door opens, and you can go to the next layer. Okay? All right, good, good. Composition, we're focusing on that this year. All right, I'm going to go back to the way I had it just because it suits me. All right, if you deviate from what I do, that's fine. Just make sure that it's correct, because you don't want to lose points knowing how to do it for notation. All right, number 2, the general limit as x goes to 2 of k of x. So once again, bring it inside. K of the limit as x goes to 2 of k of x. Again, it starts as a general limit. Let me get rid of all this. Now I'm approaching 2. As I approach 2, I'm approaching 1 from above on the left, and I'm approaching 1 from above on the right. Now, normally, we don't even care if it's approaching 1 from above or below, because it's just a single iteration. We're like, it approaches 1, boom. That's the answer. But now it's important. It approaches from the positive side of 1 on both sides. So on the next iteration, it's going to be the limit as x approaches 1 from the positive side only of k of x. Okay, because it was above. Above now becomes right side of. And now, same graph, as I approach 1 from the right side only, it's 2. And this answer is 2. If you had left it as a general limit, it would be DNE, which would be an answer choice. Okay? We're getting it. I see y'all are getting it. There's no grumbling, so that's good. Yes, Mason?
So because you make the y value of the first output,
The input of the next?
it's the, oh, that's why it becomes the, okay. Because the y value, it's like the positive and negative y value.
Yes, becomes positive or negative X values.
That's why it,
Exactly.
I was just kind of running with that.
Oh, yeah. Y values become X values. So it's like you're taking the whole coordinate plane and turning it clockwise 90 degrees. Yeah.
Is it fine if you just skip the like if you just skip here, is that fine? That's what I'm.
Yes, because you're not lying. Yeah. So, yeah. Now the question was for everybody, what if you don't even show this first step? Is showing that enough indication? And the answer is sure. Because you're not lying. That is in fact equal to that, which is equal to 2.
Which is why you're saying I can't put that one.
Correct, because it doesn't have the K of X in front.
But I can put it next to it.
Yes, next to it's
If I
fine.
need to rewrite it.
Correct. Yeah. All right. Let's go ahead and finish these. I don't want to run out of time. I do want to go back and do the warm-up. So stick with me here. Again, I'm going to go ahead and write it. I just, there's people that still like to do this. I like to be thorough in this case. And I like to make careless mistakes. I really enjoy it. So, subconsciously I do it all the time. Now this one starts as a one-sided limit. It starts as a one-sided limit. So the limit as X goes to -1 from the left of K. By the way, a one-sided limit doesn't have a chance at turning into a two-sided limit because you're only approaching from one side. It's either going to be from above or below. Does that make sense? Okay. So -1 from the left. -1 from the left. I'm approaching 0. Right. See that? I'm approaching y equals 0. I happen to be approaching y equals 0 from above 0, which, coincidentally, not ironically, are positive values. So this is from the positive side of 0. So this becomes the limit as X goes to 0 from the right-hand side of K of X. And now I'm approaching 0 from the right-hand side, which happens to be the same as the left-hand side, but it's 1. Okay? We're moving, we're grooving. And then this one here. If you're given a different function other than a graph, like you're given an equation, like 1 minus x squared, 1 minus x, or cosine, it's going to be a function that you're expected to know the graph of because you need that information to determine how it's approaching. Cosine of x as we approach 0. If you just use direct substitution, you're going to get the value, but you might get the next iteration wrong because you're approaching from both sides or one side incorrectly. So if you plug in, you get 1. So if you want to go ahead and say, yeah, cosine of 0 is 1, I just don't know if it's from above, below, or general. Chala is cosine. So that stands for high axis, low axis, high. So remember, high means it starts right here at 0, 1, and then it's axis low, and then it has y-axis symmetry. So cosine looks like this. And as you approach 1, which is right here, from both sides, you are doing so from the negative side of 1. You're not approaching from negative y values. That's not what we're saying. It's just from below 1, which is from the left of 1 when you become an input. So that becomes a one-sided limit. And once we looked at the graph of cosine, as I walked around, everyone went, ah, yeah, so from the left. So yes, that's good. Now we approach 1 from the left. And here's 1 from the left. It's approaching 1. Okay? There you go. So two-sided limits can become one-sided limits, but one-sided limits can't become two-sided limits. Okay? All right. Yeah, I said that up above. What starts as a two-sided can become a one-sided. Okay. And it can switch sides, of course. Let's go back and do the warm-up then, which, man, was a horrible, horrible segue into the lesson, but it makes a fantastic closing. Cool down, right? Use this graph. Evaluate the limit as x goes to 0, 1 minus x. Well, direct substitution, you get a 1. But what does the graph of 1 minus x look like? That's a line. You're expected to know what that looks like. It has a y-intercept at 0, 1, and a slope of -1. Down 1, right 1, down 1, right 1. So that's what it looks like. It starts as a limit from the right only. So as I approach x equals 0 from the right-hand side, I'm approaching 1 from underneath, right? Only from underneath. That's from the negative side of 1. So this becomes the limit as x approaches 1 from the left of f of x. And notice I now skipped that first step like y'all are keen to do, and that's fine. Now we approach 1 on this graph from the left, and as I approach 1 from the left, I happen to be approaching 2, and there's the answer. And listen, all you hear are the sound of people outside going to lunch. When we did this at the beginning of class, it was the sound of everybody going, "What the heck?" Right? Oh, it's a much better sound. The sound of understanding. I'm hungry. Let's go get some lunch. All right. I know, I was lying. I'm not hungry.